and welcome back to Chemistry Nuggets, where you can polish your knowledge and clear your doubts. Friends, today's video is the part 12 of Thermodynamics class 11 chemistry. In this part, we are going to study about thermochemical equations. So let's check what is that thing. It's a small topic in our thermodynamics story. It's thermochemical equation. As the name suggests, thermo means something about heat, and it's a chemical equation. So together we can say now a balanced chemical equation. What is that? A balanced chemical equation together with the values of its delta RH is called thermochemical reaction equations. Now, so in general terms, any equation, chemical equation which is fully balanced and it is denoted with its delta RH value, so then the whole thing is called a thermochemical equation. So let's have an example. We have C2H5OH in the liquid form plus plus oxygen in the gaseous form. It gives carbon dioxide in the gaseous form plus water in the liquid form. So first check is the reaction is balanced or not. So let's see carbon, how many things. Carbon on the reactant side, it is 2 carbon, reactant side 2 and the product side 2. Next come to oxygen, reactant side it is 3 2s are 6 plus 1 7 reactant side, and here in the product side it is 7 again. Now come up to hydrogen. Its reactant side hydrogen value is 5 plus 1 6, and in the product side it is 3 2s are 6. So we can see the reaction is balanced. First criteria is fulfilled, and the second point is delta RH standard is given. It is mentioned here minus 1367 kilojoule per mole. So this whole equation is balanced equation and delta RH standard is given. So now we can say this equation is called a thermochemical equation. That's it. Now some points to be remembered about the thermochemical equations, that the coefficients in the balanced thermochemical equation refers to the number of moles of the reactants and products. Now what is coefficient here? Coefficients are the numbers what we put during the balancing, like 2 is added here for carbon dioxide and 3 is added here for oxygen. So these are called the stoichiometric coefficients. So these stoichiometric coefficients are not the molecules. We can't say here 3 molecules of oxygen is added with 1 molecule of ethanol. What we will say? We will say it is a mole. 1 mole of ethanol reacts with 3 moles of oxygen and it gives 2 moles of carbon dioxide and 3 moles of water. Fine. So the stoichiometric coefficients are not molecules. These are number of moles. Second and very important point is the numerical value of delta RH standard. Here it refers to kilojoule per mole. Again, it is given in the terms of mole. So here the main point is everything in terms of mole. Now let's see some more equations and some more examples. Here Fe2O3 in solid state reacts with hydrogen gas. It gives iron in solid state plus water in liquid state. Now its delta RH standard is minus 33.3 kilojoule per mole. Now first check the reaction is balanced or not. Iron 2, done. Then oxygen 3 and hydrogen here it is 3 2s are 6. Here it is 3 2s are 6. So the reaction is balanced and delta RH standard is given. So we can say this is a thermochemical equation. One more point to be noted here, that delta RH standard value is in negative. Negative means that the energy is going out. Going out means the equation is exothermic. Correct? So by seeing a thermochemical equation, we can tell how many moles are used. 1 mole of Fe2O3, 3 moles of hydrogen added, and it gives 2 moles of iron and 3 moles of water. First thing. Second thing, it's a exothermic reaction. It means a lot of heat is evolved during the reaction. Fine. Come up to a little bit different. If the same reaction is done with the different stoichiometric coefficients, like in the first part we took 1 mole of Fe2O3. Now if we take half part of Fe2O3, then we took 3/2 part of hydrogen, and it gives 1 mole of iron and 3/2 moles of H2O. Now when we check the whole reaction, it is balanced. So first thing, it is a balanced, but the thing is, it is balanced differently. Now, so some change should be there. Yeah, the change is here. You can see clearly. Delta RH value is different. It is minus 16.6 kilojoule per mole. We can see easily the delta RH standard is different. Why it is different? Because as we already studied, the delta RH depends on the stoichiometric coefficients. So if the coefficients are different in the same reaction, if we are doing in 2 different ways, having 2 different quantities, the delta RH value will be different. Although the reaction is exothermic, the behavior will be same, but the value of heat evolved is different. Now, so this is also example of thermochemical equation. Now, one more point to be noted, very important. When a chemical reaction is reversed, now we are telling about a thermochemical equation. So let's see this equation. Nitrogen gas added with 3 moles of hydrogen gas. 1 mole of nitrogen plus 3 moles of hydrogen gas. It gives 2 moles of ammonia gas. And its delta RH is minus 91.8 kilojoule per mole. Now, clearly this is a balance equation and delta RH is given, so it's a thermochemical equation. Now, from this equation, we can see this first equation is exothermic, because delta RH is negative. So, it's exothermic reaction. But when the same reaction reverse, what happens then? If the same reaction reverse, the delta RH value will be same, but it will be now a positive. It means now it's a endothermic reaction. Can you see clearly? When nitrogen is added to hydrogen, it gives ammonia gas, and it's a delta RH is negative, means exothermic reaction. When 2 moles of ammonia gas breaks into 1 mole of nitrogen gas, 3 moles of hydrogen gas, same reaction but in the reverse direction. So the delta RH value should be same, but now it's a endothermic process. It means we have to provide the heat to start the reaction. So friends, that's all for today about the thermochemical equations. There is nothing much to tell. Just a simple knowledgeable point which will be used in the numerical point of view. So do like, share and subscribe the channel, and don't forget to press the bell icon. Till then, thank you.